So the first set of problems here, let's do A and E. Let's do A, C, and E. Right. So all it's asking for is asking the either the molar mass. That's what it means by molecular mass. That's the same as molecular weight, molar mass, all the same, or formula mass. And the only difference in those two terms, they still mean the same thing, but like formula mass would be for something like this, right? Where it's an ionic compound as opposed to a covalently bound compound. So that's all that means. But it doesn't change the operation that's necessary. It doesn't change the operation. We still take all the atoms, add them up, multiply the subscripts if we have to, and get the molar mass. All right, so for P4, what will we do here? Somebody look on the periodic table and tell me what the atomic mass is for phosphorus.
The atomic mass is 30.9737.
30.97. And this will be times 4, right? Because there are 4 atoms here. So when we do this, this will be, what is that? Calculate that real quick. What is that? 124, somewhere up in there.
123.88.
3.88 grams per mole. All right. So all of these questions are the same. And the reason I started out with these is because a lot of the other questions, they require you to find the molar mass of a compound. All they're going to give you is the formulas. You got to find the molar mass. What about the calcium nitrate? What do we do with this 2 right here? Right, that subscript has to be distributed. So we're going to do 2 times 3 and then 2 times 1. So for this formula, we have calcium, we have nitrogen times 2, and we have oxygen times 6. And the molecular or the atomic mass of oxygen is 15.99, and then nitrogen is 14. What's calcium? Should be 20 something, 23, 24, something like that. Is that right?
The atomic mass for calcium is 40.078.
40.08. All right. And you know these are all in grams per mole. So when we add them up, that's what that's gonna be. Let's say let's just round it to 96, and then 28 and 40.08. That's gonna be 136.08 plus 28. We get what 164.08 grams. Right. The key is to understand those subscripts have to be, they mean that you have to multiply. So when you have a subscript, you got to multiply through with that subscript to make sure you get the proper stoichiometry and the proper masses. All right, let's do the last one. Sucrose. So you got 12 carbons, 22 hydrogens, and 11 oxygens. Right, so that's going to be what? 12 times 12.01. That looks like 17, my bad. And it's going to be 22 times 1.008. And it's going to be 11 times 15.99, all in grams per mole. That's my units for molar mass, grams per mole. All right. What do you got from that? This is 144.12, and this will be what 22 point
176.
yeah, 22.176. And then this will be 11 times 15.99. What you got for that?
175.89.
175. So we'll just add all those up, and the sum will be the molar mass for sucrose. Anybody got it yet?
342.186.
342.19 grams per mole. Right. So this skill of calculating molar mass that spans across everything that we're going to be doing from here forward. All right. So right here, all you have the structure and not the formula, but based on the structure, you can still get the number of atoms, right? So let's do the first one. That's 2 chlorine. So that's 2 times 35.35 for chlorine. You got 1 carbon and 1 oxygen. Right. So this is the structure for basically we could write this like this, right? COCl2, right? So same thing. This is the Lewis form for that molecular formula. So what do we have? So 70.70 plus 12.01 plus 15.99. Anybody got it? Need to get my calculator too. This is the only one I didn't.
98.7.
Say again.
98.7.
Okay, grams per mole. All right, let's do one more because I think you have the hang of this. All you need to do is be able to read the periodic table and find the masses, and then make sure you got the correct number of atoms times that mass. All right, and that's the way we'll handle this. So this is 1 sulfur and 3 oxygens. Well, 4 oxygens, sorry, and then 2 hydrogens. All right, so that's going to be what? 4 times 15.99 for oxygen. Sulfur will be 1 times 32. Hydrogen will be 2 times 1.008. All right, and this is sulfuric acid. And you'll see this sometimes written out in condensed form like this, H2SO4. So 64, 32 is 96, and be 98 point what?
I got 97.976, so it'll be 98.7 or 0.0.
Yeah, you can round it up. You said 98.976.
Yeah.
Yeah, or you can write it 97.98. Or you can round up to 98, but depending on how many sig figs are required. But we'll leave it like that, 97.98. Good. All right, so that's that. That's molar mass. We've done that already. That was the first thing we covered. So now we're gonna go back and let's do a couple of examples here where you actually have to, and these are a little bit more involved. So look at what it's asking. Determine the number of moles of compound That's the first thing. So we're gonna say that that's A. It's a two-part problem. And then B is right here. And the number of moles of each type of atom, right? So it's a two-part problem. First, the number of moles of compounds. Second, the number of moles of each type of atom. So the way we do this, moles of compound is what? Grams over what? Molar mass. If we know the mass of the compound in grams and we know its molar mass, we can get moles. The way we're going to do this is through percent composition. So we're going to use percent composition to do that part. All right. So this is our compound, propylene, C3H6. What's the first thing we got to do? We got to find this. We have the grams, 25 grams of propylene. We don't have the molar mass. But if we have the formula, we can determine the molar mass. So all we need to do is take this and do what? 3 times 12.
I got a question.
Go ahead.
So like with this, wouldn't we like split up the 3 carbons and the 6 hydrogens, then multiply them and then set those set the grams over the molar mass of those? Or will
Yeah.
we put both of them together?
No, you're right. So we're going to sum them up to get the molar mass. We're going to separate them when we do the percent composition. But you're right. We need both atoms, carbon and hydrogen, to find the molar mass, and we need the numbers of each of the atoms to find the molar mass. So we got 6 hydrogens and 3 carbons. Did that answer your question?
Yes, sir.
All right. So let's get this. So this will be 36.03
03.
grams per mole. We're gonna save these numbers because we can use them later for the percent composition. And this is 6.048. Is that right?
Yeah.
So 6.048 for a total of what? What's that? 42.078. Grams per mole. All right, so that's my molar mass. So now that we have that, we can figure out the moles of compound. So this is for part A. Moles of compound is going to be what? 25 grams divided by the molar mass, which is 42.078 grams per mole. All right, what we got there?
0.59.
0.59 moles. All right, great. So now we know we got moles of compound. Now it's asking us for the moles of each atom. So here's the thing. If we know the atomic masses of each atom, which we've already calculated, like this, the total molar mass is 42.078. And we know that carbon is 36.03 and hydrogen is 6.048. So when we find the number of moles, they should add up. Those two atoms, when we sum them up, they should add up to 0.59. So let's do that. So let's do percent composition using the numbers we calculated here in the total. So now we're going to do part B. We're going to do first percent composition. And the rest of these problems are identical. Find the molar mass, find the moles, and then for the second part to find the moles of each atom, you're going to do percent composition. So for carbon, we already know that it's 36.03 divided by the total, 42.078. And that's going to, and we multiply that times 100, that's going to give me my percentage. And then for hydrogen, it's going to be the same thing, 6.048 divided by 42.078. All right, and both units are grams per mole, but they're going to cancel. So we don't need that. What's the top one?
0.85.
So 85%. And then the bottom one is what?
14.
So it got to be 14 point something, right?
It's 14.3, but yeah.
0.3. And the top was 85.7, something like that. Before you
It was
run.
85, 80, 0.856. So you can say 86.
Yeah, right. So 86. We're gonna round that up to 86. So it's 86% and then 14%. Y'all following that? So what we're saying is that this compound is 86% carbon and 14% hydrogen. Now, when we did this on yesterday with the morning class, I had them find the grams first and then go back and find the moles. But we can actually take these numbers and now apply it. So if we take 86% of 0.59 moles, that's going to give us the number of moles of carbon. So we could say, I'm going to say use the fraction 0.86 times 0.595. So this is the percentage, and this is the total moles. Not totals. Come on, Russell. So we can find out how much of that those 0.595 moles are carbon. We'll do the same thing here. We can take 0.14 times 0.5. Let me sharpen this pencil up some. 95. Again, that's the percentage, excuse me, percent and total moles. All right. Any questions about that? So there's a longer way to do this, right? We say it's 86% carbon, and then we can take that 86% and find out how many grams out of that 25 grams is 86%. And then we can take those grams and divide by the molar mass to get the moles. We could do that. But since we already have the number of moles determined, and that was to be 5.9, we reported 5.9. Since we already had the number of moles determined, once we find the percentages, we could take the same percentages and just as well do take the percentage of the moles, just like we could of the mass. But it's asking for moles, so let's just take the moles and figure out how much 86% is of 0.59, how much 14% is of 0.59, and they should add up to 0.59. So what do you get for the top?
0.5117.
So 5117.
Yes, sir.
What about for the bottom?
0.83.
Is it 0.83 or 0.083?
0.083.
All right. And that adds up to 0.595, which is, if we didn't round, it would be 0.595. So we're going to leave it. All right. But for this question, it's a two-part question. First, you have to find the number of moles of the compound, which is the total mass of the sample divided by the molecular weight of the compound itself. And then for the moles of each atom, you have to do percent composition. So it's the part over the whole. 36 is the part that's carbon divided by the total molecular weight, which is 42.078. Same thing for hydrogen. And then you get those percentages. And from that, you can figure out, if you just multiply the percentage times the total number of moles for each one, you'll get the moles that each one represents. All right, I know that was a lot, but let's do one more. Let's do a hard one. We're gonna do C. If we can do A and C, then you can do B on your own. So I'm gonna cut this out and add a page. Because this is a long problem and it's gonna take a lot of space. All right. Let me paste that in. So we got this herbicide, Truffland, and it's telling us that we got 25 pounds of it. And it's giving us a conversion from pounds to grams. Why do we need that conversion from pounds to grams? What did the question ask us for? Moles, right? So we can't do anything with grams, but we can take grams and turn grams into moles. So this is, I'm gonna write the description of what we're gonna do here. First, we're gonna convert 25 grams. I'm sorry, 25 pounds into grams, and then into moles. How do we convert pounds to grams, right? We need a conversion factor, which is going to be what? 1 or 454 grams over 1 pound. And then how do we convert grams to moles? We need what? Grams over what? Molar mass. That's the first part of the problem. And then in the second part, we're going to use percent composition to find the moles of each atom. All right, that's what we're going to do. And we know, and we did it just in the other problem, we just did with a different formula. All right, so first thing we want to do is convert pounds into grams. So let's do that. We're going to take 25 pounds. We're going to multiply it by 454 grams. And that's my conversion. What's that number?
$11,350.
Good. So 11,350 grams. So now we're good on that. Now we need to go from grams to moles. How are we going to do that? What are we missing that we need to calculate or derive?
Molar mass.
Molar mass. That's our conversion from grams to moles. That's how we get there. And so it's going to be grams over molar mass. Well, we don't know what the molar mass is, but we know how to get to it because we got this formula up here and it's telling us the total number of atoms present. So this is going to be what? 13 times 12. Is that right? Because we have 13 carbons. And the atomic mass of carbon is 12.01. And this is going to be what? 16 times 1.008. And then we got 2 nitrogens. So it's going to be 2 times 14. Got 4 oxygens. So that's going to be 4 times 16 or 15.99. And then 1 fluorine, which is 19. 1 times 19. Right. So let's find that molar mass. We could Google it, but I much rather calculate it because that's good practice. So this is gonna be 156.13. This is gonna be 16. Mm, 0.108, if I'm not mistaken. And
I
this
got 16.128.
128. Yeah, my bad. 128. And this will be 28. And this will be roughly 64 and 19. So sum all those up and we'll get the molecular weight of that compound in grams per mole. It's a big compound. I wonder what the structure is. I'm gonna Google it while y'all are doing the math. It's not that bad. All right. Anybody got the mass, the molar mass calculated yet?
283.218
All right.
grams per mole.
You said 218, so let's say 22 grams per mole. All right, good. Now can we do the first part? Can we do the first part now? We can take what? 11,350, is that right? 11,350 grams divided by 283.22 grams per mole, and that's going to give us moles. What do we got?
$40.07.
Okay, great. 40.07 moles. That's the total. So when it's asking for the number of moles of each atom, every one of those atoms, when we calculate the moles, the sum should add up to 40.07. Are you following that? Like that the atoms are not going to disappear. The total number of moles is not going to change. When we find out the percentages of each one of these atoms, right, we'll know that when we sum all those numbers up, that should add to 40.07. So let's do that. So let's do percent composition. And then we're going to take our percentages and figure out how much each percentage is of 40.07. So for carbon, we've already done it. We've done 13, we got 156.13 for carbon divided by 283.22 times 100, right? So for carbon, we've already calculated the individual masses when we were doing the molar mass, right? So all we got to do now is go in and use those same numbers we already calculated. So for hydrogen, it will be 16.128 divided by 283.22 times 100. Is that right? Because again, once we went through and did the molar mass, that's why it's important to do it manually and not just Google it. Because now all you got to do is take those numbers and plug them in here to figure out the percentages. For nitrogen, it was 28 divided, it would be 28 divided by 283.22 times 100. And again, these numbers, the units are grams per mole, but because both numbers are in grams per mole, the units are going to cancel. All right, so NO would be, what do we have for oxygen? 64. And then fluorine was just one fluorine, so 19 divided by 283.22 times 100. All right, what do we have? Somebody give me one person to give me one of each one. You can just unmute.
Carbon is 55.13.
Okay, great. Thank you. We got anybody for hydrogen?
Got 5.69%.
6, 9. All right, good. What about nitrogen? It should be close to 10%.
Nine 9.89%.
Good. Oxygen. Is it 22.59 or 22.6? And then fluorine. Somebody give me that one.
$7.98.
That's 7.98%. All right. We're getting a different number for fluorine. We're getting 6.7%.
That's what I got, sir.
It's 19 divided by 283.22. I'm getting 6.71%. All right. So now we got the percentages. We can take these, the fraction, obviously that's before you multiply by 100, and then just figure and multiply that by 40.07. So it's this fraction 0.5513 times 40.07 moles, and that's going to tell me how many moles of this total is carbon. Are y'all following that? Does that make sense? So we take those percentages, and each percentage is a part of that total of 40.07 moles. We do the same thing for hydrogen, 0.0569 times 40.07. And that'll be moles of hydrogen. And then we do the same thing for nitrogen, 0.0989 times 40.07. And then this is nitrogen. And then for oxygen, it'll be 0.22660 times 40.07. And then for fluorine, same thing, 0.0671 times 40.07. And when you get the number of moles of each one, you should be able to sum them back up and they should equal 40.07. That's how you know when you did it right. The percentages, if we took those percentages and figured out, we could figure out the grams, and the grams should all add up back to 25 pounds or 11,350, or we can take it and multiply by each percentage by the total number of moles, and we should get what part of that whole each one of those is. All right. Any questions about that one? All right. So I want you to, at some point, you can knock this one out. It's the same type of problem, right? It gives you the grams to begin with, and it gives you a molecular formula so you can find the molecular weight, figure out the moles, and then once you figure out the total number of moles, use percent composition to figure out each individual atom, how many moles each individual atom represents. All right. Questions? Any questions? All right, we got time to do a couple more. I want to let y'all go and enjoy spring break, but Thursday kind of monkey wrenched us. So we're gonna cut this out too. Put this. Just white it out. All right, so it's asking us, this is familiar, we know how to do this, right? It's all we're doing here is we're going to be manipulating the relationship between grams and moles. That's it. So it says determine the mass of each of the following, and it gives you in moles KOH. What do we need if we want to go from moles to grams? It's asking us to find the mass. So that's in grams. And it's giving us moles. All right, how do we do that? What's the relationship between grams and moles that we know and we can always apply? Grams over molar mass equals moles. Is that right? So now we know what we have. We have all these questions are the same. What do you have? What do you need? And sometimes you have to take what you have to derive what you don't have. So we don't have a molar mass, but we have a formula. And because of that, we can figure out what the molar mass is. All right, what's the mass? What's the atomic mass of potassium? Based on the periodic table. Is it 39.01? Or 10, 39.10, my bad. And this is grams per mole. And then the OH, let's just leave that together. Right, so now we can figure out the molar mass of KOH is 56.10. Once we get this number, and we have moles, and we're looking for grams, we can just do what? Manipulate this equation or this relationship. So molar mass times moles equals grams. Right? So we got the molar mass, 56.10 grams per mole. And we're going to multiply that by 0.0146 moles. Moles are going to cancel, and we're left with grams. What's that number? Anybody got it?
$3,842.4 5466.
You multiply 56.10 times 0.0146. I'm getting a different number.
Oh, oops. I hit divide.
Oh, okay, yeah, I was like, man, that's a lot.
I got 0.819.
All right, so this is 0.819 grams. So what that's saying is that if I have a sample of KOH and it's 0.0146 moles of KOH, that's the same as 0.819 grams. When you're working with, we're working with KOH in a lab, this is what you weigh out on the balance, 0.819 grams. And then you can use the molar mass to figure out how many moles that is. Because we don't work in moles in the lab, right? We work in grams, stuff that we can actually measure. Moles are derived, but the grams we can actually measure that. All right, let's do one more. And it's asking for the mass, and we got 6.854. Let's do D. We got it's giving us 6.854 times 10 to the third moles of glucose. And this is glucose. Same type of problem, and it's asking for the mass in grams. If you're given moles and you're given a molecular formula, then you can find the mass, because right here we just manipulated that relationship. Molar mass times moles equal grams. So what are we missing here? What do we need to find? Right, got to find the molar mass. And I think, did we already? No, we did sucrose up top. But we know how to do that. Right, 6 times 12.01, 12 times 1.008, and then 6 times 15.99. That's how we're going to get the molar mass of glucose. And once we do that, it's just a matter of putting a number in it, putting the numbers into an equation like this. We got moles already, 6.854. Right? Can somebody just Google glucose, the molecular weight? 72, 84, 80.64. No, it's not. It's one, is it 180?
Yes, sir. I got 180.16.
All right, and that's it. Once you multiply those two numbers together, then you're going to get grams. All right, unfortunately, we have to stop until after spring break, which is a bummer, but that's okay. We'll be back. Hopefully you all have a safe break and enjoy yourself, get some rest,